All right, this video is going to take you through the Now Serving project. We're going to look at the design requirements and the grading rubric. This is a challenging circuit. It does not have a lot of support in the curriculum, so it's not the kind of circuit where you can flip into PLTW and they'll give you a design and you just have to replicate it on Multisim. This is one that you need to generate and show what you know of the different circuit components and how they work. To put the project into some context, the Now Serving project is modeled off of, say, a deli. If you go to the deli counter in a shop and there's a digital display that tells you who they are serving. And so you walk up to the counter and essentially you take a number, let's say you take the number 35, and you watch the little counter go up. So it'll say now serving number 33. And somebody steps up, they serve them, they get them their meat, whatever they want. And then the worker will click the little button and it'll say now serving number 34. And whoever's got number 34 goes up to the counter. And when they're done serving that person, they click the button now serving number 35. And when your number comes up, you know that now you're the next in line. So it's a way of creating a digital line. Everybody takes a number and then the digital display will tell you where in the line you are. So let's take a look at the design. So you are to design a digital circuit that displays the count from 00 to 80. So this particular deli will serve like 80 customers before their counter runs out. The design requirement is for 2 control inputs and 2 output displays. So 2 inputs are next and reset. The next signal comes from a push button switch that when pressed advances the display by 1. So one of your inputs is essentially going to clock the counter, okay? And when you push it, it's going to advance the counter up to the next level. The reset signal, which is also a push button switch, will reset the display to a count of 00. So you get to the end of the day, you are sitting at number 65, and you're not going to start at 65 the next day. So you hit reset and it will clear everything back to 00. When the display reaches 80, the count will cease. The employee at the deli counter takes a break, and a new employee takes over after the counter after the 80th customer is served. So maybe they have some kind of negotiation in their contract where you only have to serve 80 people, and once it hits 80, you're on break and the next person comes in. It's the scenario they give us. Now, what it means by when it reaches 80, the count will cease. What that means is that when you keep hitting the next button, it won't count any higher than 80. And so you can keep hitting next, but it's not going to go to 81, 82, and it's also not going to loop back to 0. It's got to hold at the 80 until somebody comes and presses reset to get you back to the 00. So if you need to, take a moment, pause the video, reread this, or maybe rewind the video, and maybe if you hear me explain it the second time, it'll make more sense. I don't know about that, but you can try. Or you might want to ask a question or at least file a question that you want to ask me when you have a chance. Right, so here are the design specifications. So these are the requirements that you need. The 2 output displays are common cathode segment displays, and I am going to give you a change on that. But that is how it's designed. So common cathode CK, 7-segment display. CK, I have to look up at my board. That's the one that's grounded. We remember. The 2 displays require multiplex design. That'll be fine. That's just means like do the design the way you have been. Now you'll notice we have a couple asterisks. This is the major change. The ones unit display, that's your least significant digit. So the one that's counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 2, 3, 4, that one is controlled by an asynchronous counter designed with the 74LS93 MSI counter. So you're going to use MSI Tech for your ones digit. Don't worry about the PLD mode equivalent because we haven't done anything in PLD mode, so don't worry about that. The tens digit or tens unit, that's your most significant digit, is controlled by an asynchronous counter designed with SSI logic gates. That is, you're going to design the counter with flip-flops. And so you'll be counting up 0 through 8 on the tens digit, which means you would need 3 flip-flops. Okay, 3 flip-flops wired together to form a counter. So the ones digit is MSI. You can use a chip for it. The tens digit is SSI, your flip-flops. Any additional logic may be used as needed to support the counter designs. And then this one, add a design feature that holds the count when it reaches 80. So that is kind of a new one. You just have to think about that. So here are the changes that I have made to this. And this is mostly for the interest of time. Okay, because if we do all of that, some students are going to get really bogged down. This is a lot. This is a lot in the design to get your head around and to start building your counters. So you may use either SSI or MSI tech for the ones and the tens digit. I am not going to tell you you have to use specific tech for the ones digit and then another kind of tech for the tens digit. Just as so you can use MSI technology for both. Just make sure that you know that tens digit needs to hold at an 8 and it needs to be able to hold at an 8. Okay. Or you can use flip-flops for both of them. That's fine. Whichever one of those you're more comfortable with. Now you may also use a hex display to save time instead of using the CK 7-segment displays. So it does say in that first bullet point that you need to use common cathode 7-segment displays. If you would like to use a hex display, that just saves time. The common cathode displays have to be grounded and you have to run all those resistors into the display, where the hex just have the 4 inputs. And yeah, so you can use a hex display. You don't have to deal with the grounding. It just saves time. And the other one is you may use a single pole double throw switch instead of a push button switch. So we haven't really wired anything with the push buttons. You might need to look that up to see how you would wire the push button switches up. The push buttons are kind of nice because they simulate what we would be doing in real life more. We would have usually a push button, not a switch. But because you're more comfortable with the SPDT switches instead of the push button, you're welcome to use those instead. Now, as the trade-off, I will give you bonus points for designing as specified using MSI for the ones digit and SSI for the tens digit. So where those asterisks are, if you design it that way, it will be worth bonus points. You will get a bonus point for using the push button because that's going to require a little extra work on your part to go and figure out how that push button works to get it in there, and some bonus points for using the 7-segment displays. It's kind of going through the bother of wiring up those displays. Now, how are you going to be graded? All right, so this is how I project to grade this, because again, this is a big one and I am willing to give you guys some class time to work on this, but we're not going to grind the course to a halt, barreling into our testing season, which is just around the corner. So you get a 0 if you don't submit a circuit. So I need to have something put in my hands or on my screen, so to speak, to evaluate for you not to get a 0. I think that's pretty reasonable. Anywhere from 9 to 15 points. Any submission that shows good effort and attempt, but basically your circuit does not function. So 9 points is, I think, a 30% up to a 50%. If you have something that shows good effort, but honestly it just doesn't do anything, it doesn't do what it's supposed to, you're getting bizarro stuff on your displays, there's no order to it. But like, I know you sat in my class, you did try to do this assignment. Now, to pass, minimum passing, that's 20 points. That's actually like a 66, I think, 20 points out of the 30. Your circuit counts, but the ones and tens digits do not trigger in the correct places. So you're pushing your button or you're flipping your switch and it's like counting sort of, but it's not. Like when you get to like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like it should trigger the next one to go from 0 to 1, and it's not. Okay. Or you're skipping numbers, or it's counting like 3, 4, 5, 3, 4, 5, like doing something like that. So it counts, but it's not counting in a way that's helpful. Okay, so we're making some progress. To earn a C, the circuit successfully counts 0 to 80, but it does not hold at the 80 and the reset button does not work. So basically, if you can put together a circuit that counts 0 to 80, but then when we keep clicking it, it like keeps going, like 81, 82, 83, 84, 85, and you can't make it stop, and it, or it like goes 80 and then it goes back to 0, 0 without ever hitting the reset button. Okay, so that would be, yeah, and the reset button doesn't work, so we can push the reset button and it doesn't do anything. Okay, or it sends the count to somewhere else, like we hit reset and it goes to 23. Okay, so that would be a C. So we've got like the two displays working together and they're counting, but these added little features of the holding at the 80 and the resetting doesn't work. To get a B, the circuit successfully counts 0 to 80, and either the count does not hold or the reset button doesn't work. So one of those things works and the other one is not working. So the reset button doesn't do anything, but you figured out how to make the count hold at 80. You're just stuck there for all eternity because your reset button doesn't work. Or your reset button works, but you can't get the count to hold at the 80, so it keeps counting. Or it resets on its own without the reset button. Like that would also work, fall under like the count's not holding. So to get a B, you got to get one of those two things in place so it's working. So that would be 26 out of the 30 points, which is a fairly good B. I think it's like an 87. And then to get the A, that would be 30 out of 30. The circuit successfully counts 0, 0 to 80, and both the count holds at 80 and the reset button work as intended. So we can keep hitting that next button forever and it holds at the 80. The only way to go back is to get that reset button to work. And it works. So basically the circuit does everything that it is supposed to do according to the specs. The bonus points are awarded for the following. I will give you 2 bonus points for using a combination of MSI and SSI tech. That means, and the reason I put more bonus points on that is because that really does showcase more of what you know, that you are able to design the counters using both kinds of ways of using it. Half a point for using the push buttons instead of the switches. That's a simpler ask. It is doing a little bit extra than what I'm requiring, but it's not a huge deal. And a half a point for using the 7-segment displays instead of the hex displays. So you have an opportunity to score a couple extra points in there. And then the last part is I reserve the right to issue point values in between those stated based on issues, I don't know what it's actually under my head there, or individual problems and troubleshooting that may occur in any specific situation. So I know I put on that rubric, like you jump from a 23 to a 26, but it's also possible that I might decide that like a 24 or 25 is better. And that's really going to come down to the fact that what your circuits do are never going to fit nicely in a rubric. And so, I can say it counts 0 to 180 and somebody gets it going 0, 0 to 80 and it skips 71 for some reason. And that's the only thing it skips, that's, weirder things have happened. Or, if it's one of those situations where you're looking at your circuit and I'm looking at your circuit and we just honestly can't figure out what's wrong with it. We just cannot figure out what is wrong with it, that it's not working. You start getting a weird error message. And that might warrant moving in between those somehow. So I'm just going to put a little disclaimer that I do reserve the right for that. Otherwise, my circuit, what I'll do in class is I will play for you my circuit so you can see what it's supposed to look like. And then you will be on your own to design and build this. And I'll see you at the end. It's a wild ride.